All right, number 3, we want to find the degree and the leading coefficient, and then we have a part 2. Okay, so when your polynomial like this is in standard form, meaning it's already been multiplied and simplified, finding your degree is as simple as finding the largest exponent of any individual term. So 2 is the biggest exponent, so that is going to be the degree of this polynomial. And then the leading coefficient corresponds to the number, the numeric value in front of that variable with the highest degree. So in this case, it would just be -5. Okay, so part 2 wants us to describe the end behavior. All right, so the way we do that is you look at your leading degree and your leading coefficient. Because this is even, that means either both ends will go up or both ends will go down. All right, because of the negative, so if it was positive, they would go up. Since it's negative, both ends are going to go down. And the way we describe end behavior is we say, as x goes to -infinity, which just means as we go to the left side, because negative is on the left, then we say our y value, or f of x, is going to negative infinity, because it's going down. So as we go to the left, negative, the y value is also going negative. And then we also say as x goes to positive infinity, so on the right side, as we trace this graph further and further to the right, the y value is still going down toward negative infinity. So this is the notation of how that is read and written. So f of x is going to negative infinity in both scenarios. So anytime you have an even degree, they're going to be going the same direction, either both to positive or both to negative. So they just have it written in the opposite direction. They have the y value goes as x goes. They just kind of flip the structure, but it says the same thing. All right, number 4, we're going to be doing something similar. So we want to find the degree and the leading coefficient of Sx. Now, this is not in standard form. These terms are being multiplied together, so you would really want to distribute and multiply these together. However, you don't have to. You can simply count the variables. Now, if these x's had coefficients on them, then it would probably be better to multiply them out so you can get the leading coefficient. However, I think you can see the sign no matter what. So let's talk about this. We're going to count the number of x's because when you when it's not in standard form, just think back to properties of exponents. So if you had something like x squared times x to the third, for example, the property says if you have the same base and you're multiplying, you would just add those exponents. So you would do 2 plus 3, and that would give you x to the 5th. All right, so that's the idea that you have to keep in mind here. These are being multiplied, so I'm going to be adding them together. I have 1x here, plus another one would give me 2x's, plus these 2 would give me 4. So in this scenario, your degree is 4. If it's in standard form, you can just see the biggest one. However, when it's not in standard form, as this one is not, you have to add the terms together. And you will notice it because you'll see them in parentheses butted up against each other, meaning that you need to multiply. All right, the leading coefficient is going to be the numbers. When you multiply the numbers in front of those x's, so this is just 1 times 1 and then times a -9. So we get a -9. All right, so again, with number 4, we have a negative and then we have an x to the fourth. So we have even and negative, so it's going to be the same scenario as we did in the previous one. Even is going to give both the same direction. Negative, they're both going to be going down. So both my y's are going toward negative infinity.